Okay, you'll notice the objectives for today. Tell the difference between speed and velocity. So that should already indicate to you on that agree or disagree that they are not the same thing. Okay, calculate average speed. We're going to learn how to do that. And then read a distance and time graph. Okay, so if we get to the end of class and you can't do one of those things, come see me. You missed something. Okay. All right, first thing we're going to do is we're going to go into the gym for a minute. I promise I didn't make you do stairs just to be mean, okay? As you moved up and down the stairs in the gym, I want you to tell me, and you can type it down too, how did your motion change?
I went slower going up, faster going down.
Okay, so your speed changed. Slower going up, faster going down. Direction probably changed, right? You started off as you're going up, going north, and then you guys moved west in the gym, and then south as you were coming back down, and then east, and then you went back up. And so both your speed and your direction did a lot of changing. Okay? So as we talk about speed and velocity today, we're going to hit back on those concepts. Okay? All right. Speed is a measure of the distance an object travels in a specific amount of time. Okay. So you take distance traveled divided by time. Okay, that's speed. Okay. Speed has lots of different units. Here are some common ones that you will probably see throughout this chapter. Meters per second, miles per hour. Okay, you might even see kilometers per hour. Because speed is a measure of both distance and time, you should have a unit that has a distance measure and a time measure in it. So meters is your distance measure, seconds is your time measure. Okay? If you don't have both of those, you have the wrong unit. And you're going to note that both on the homework and on tests, if you do not include a unit, I will dock you points. So you have to put a unit on the end of all of your measurements. Just a number as an answer for a calculation question is not enough. I'm not going to count the whole question wrong, but I will dock you points. Did you move at the same speed the entire time you were in the gym? No. We had some people say, well, I went slower going up, I went faster coming down. Okay, so your speed changed. Speed can be constant. So constant speed is when the same distance is being traveled every second. So if I'm always moving exactly 1 meter every second, my speed is considered constant. This would be like a car with its cruise control on. It should be moving at a constant speed. Speed can also be changing. Obviously, sometimes we move farther in a second than others, and even a car with cruise control on doesn't always move at exactly the same speed. Okay? So consider yourself in the gym as a good indication of this. And then sometimes we will measure what is called instantaneous speed. This is the speed that would read out on your speedometer. So it's the speed you are going at that exact moment in time. This is hard to calculate, so most of the time in class we will not be using instantaneous speed. We will instead be using something called average speed. All right, so average speed is total distance divided by total time. So remember how one of our agree or disagrees was that constant speed and average speed are the same thing? Well, that should have been a disagree because constant speed means your speed is never changing. Average speed means even though your speed changed over this course of time, sometimes you were going fast and sometimes you were going slow, we're going to average it out and get what your average speed was. So you just find the total distance someone has traveled and you divide it by the total time it took them to travel it. So when you are driving from here to Norfolk, there are places where the speed limit is 65. There are places where the speed limit is 25. There are places where the speed limit is 45. But if we took your total miles traveled by your total hours traveled and we divided them, we would get your average speed for the whole trip. And this is the one we are going to use most often here in class because it is the easiest one for us to calculate. Here's some practice for you. Let's do this one. It takes Ahmed 50 seconds on his bicycle to reach his friend's house, which is 250 meters away. What is his average speed? So use the above formula to solve. So if we're solving this, we would be taking total distance in meters, 250 meters, divided by total time, 50 seconds. 250 divided by 50 is?
25.
5. And then the unit should be? Meters per second. Okay, so you can either write it m/s or you can write out the words meter per second. I will accept either one. Sure. All right, second practice. Truck driver makes a trip that covers 2,380 kilometers. It takes him 28 hours. What is his average speed? All right, so to do this problem, we take total distance, 2,380 kilometers, divided by total time, 28 hours. Did anybody do the math on this one? You get 85, and then our unit should be? Kilometers per hour. Okay, gotta have distance and time in that unit. Okay, moving right along. Okay. We often use graphs to represent information about distance and time, and we call them distance time graphs, which makes sense, right? So on a distance time graph, when you have a line that is straight, like this line, okay, moving up or one moving down, that means they are at a steady speed. Their speed is constant. Okay? If you have one that is steeper than the other, so for example, this line is much steeper than this line, it's still going at a constant speed, it's just faster than this speed. If you have a flat line, that means the object is not moving. Because if you think about it, this is distance. If their distance isn't changing and only the time is, they're not moving, are they? If the line is pointed down, they're moving at a constant speed, but they're just returning backwards towards the position that they came from because their distance is going down, right? And then this curved line, like this, means that they are speeding up because they're covering more distance for every unit of time. So you get a curve. They're going faster. So straight line means a constant speed. A flat line means they are not moving. And a curved line that swoops up like that means they are increasing their speed. So lots of information we can get from a distance time graph. If you have a distance time graph that actually has numbers on the side, okay, that indicate distance and time, you can also use this to calculate average speed. Just like we did on the previous question, we just need to find total distance and total time. So let's look at the blue line. Okay. What is the total distance the blue line person traveled? Yeah, we go up to the end of the line and we see they traveled 10 meters total. Okay? And how long did it take them to do it? 2 seconds. So total distance, 10 meters divided by total time, 2 seconds. How fast were they traveling?
5 meters a second.
5 meters per second. Okay? Before it's stationary, so we're not counting the time after it's stationary, what was the average speed for the red line? Well,
4 seconds.
they traveled 8 meters and it took them 4 seconds. So 8 divided by 4 is 2. So they were traveling at 2 meters a second. Okay? So you see how you can use this graph to find your average speed? That is one of the things you will be required to do on your homework. All right. Last little piece of information here for you. When you report both the speed and the direction of an object, you are reporting its velocity. So there's our other agree-disagree statement. Speed and velocity are not two different names for the same thing, because if you are reporting velocity, you must report a direction. This means your velocity will change if your speed changes in any way, so if you speed up or if you slow down, but your velocity will also change if you change the direction you are traveling in. Even if you maintain a constant speed, if your direction changes, your velocity is changing. Or if both your speed and your direction change, obviously your velocity is still changing. All right, that is the end of your notes. So we are done with notes. Your homework is the 1.2 check for understanding that I will put up right now.